Hello everyone, I am Dr. G.B. Davre from Kekewag Institute of Engineering Education and Research, Nasik, Department of Chemical Engineering. Today's lecture, we will try to learn mixing and agitation vessel, and what is the importance of the baffling tank. So starting with the mixing, what is basically mixing? One simple example is that when we add salt in a water, salt and water, if both are initially separated, we take a salt and add in a water. That is nothing but the mixing, right? So mixing may involve the mixing of the gases, liquid or solid in any possible combination of two or more constituents. So there may be more than two constituents, right? They are combined to form a uniform mixture. That is nothing but the mixing. As I given you the example, if you take the salt and if you add in the water, that is a mixing. But mixing is accomplished by the rotating action of the impeller. Yes. Now you have added the salt in the water, and if you use the spoon, right? If you have the spoon, you are using the spoon, the circulatory motion is formed. That is nothing but you are doing the agitation. You are using that impeller, right? So that is agitation. So mixing, basically it is combination of the two phases or single phase of the constituent which are initially separated, and agitation is just the support for the mixing operation. That is the main difference between the agitation and mixing. So as I told you, mixing and agitation are not same. Agitation refers to the induced motion. I just given you the example when you are taken the water in, let's say, a vessel or in a cup, and you add the salt, and you are providing the rotation by using the spoon. The circulatory pattern exists, right? So agitation provided the motion for the liquid. And why the motion is provided? While we are using the spoon to improve the performance of the mixing operation. So agitation refers to the induced motion of the material in a circulatory pattern inside the vessel. That's about the agitation and mixing. And mixing, basically it is a random distribution of two or more initially separated phases through one another, right? So salt and water, these are the two phases. Salt is a solid, water is a liquid. These are separated initially, then you add it, it becomes uniform, and with the help of agitator, you have provided the circulatory pattern, so your mixing performance has been increased, right? Now the practical aims of mixing to understand is very important. Mixing operation is widely used in most of the chemical industries. There are numerous applications of the mixing operation. It is most important to use the mixing in the chemical industry, since intimate contact between the reacting phases is necessary for the reaction to proceed properly. Then next one is to produce simple physical mixture of two or more divided solids or liquid which are separated. So to have the mixture, then to increase the contact, for these purposes, generally the mixing operation is used. Sometimes there is a requirement for the final product. So that's why again the mixing can be done to meet the required specification. So these are the important practical aims for the mixing. Now we came to know mixing is different. We came to know mixing and agitation both are not same. But what are the purposes of agitation? Why agitation we have to do while mixing, or what are the benefits when we provide the agitation in a mixing vessel? First of all, suspending the solid particle. If you are having the mixture of the particle in a suspension, then when you agitate that mixture, the particle which are having lighter density, which will suspend, and that's how it can be very easy if you want to separate out those particles from the mixture. So suspending the solid particle, this is one of the purpose of the agitation. Second, blending miscible liquid, for example, methanol and water or ethanol and water, both are miscible. So you can blend them, you can provide the agitation, and this can be done quickly. Dispersing gas through the liquid in the form of small bubbles. If you want to disperse the gas from the liquid, then also you can have the agitator. Promoting the heat transfer between liquid and jacket or coil. Jacket are at the outside of the vessel and coils placed inside. So if you want to increase the heat transfer between the liquid, then you can have the agitation. Dispersing a second liquid immiscible with the first to form emulsion or suspension of fine droplet. So these are numerous purposes of the agitation. So these purposes we must understand: suspending the solid particle, blending the miscible liquids, dispersing the gas through the liquid in the form of small bubble, promoting the heat transfer between the liquid and jacket, dispersing a second liquid immiscible with the first to form emulsion or suspension of fine droplets. Now let's talk about the agitation vessel. This is the agitation vessel. As you can see, this is basically the vertical vessel where the impeller, which is provided at the center. Impeller is nothing but the agitator, you can see. Then the liquid, see the liquid is around 60 to 65% of the height of the vessel. Then the strips are mounted. These are the strips are mounted at the wall of the vessel, that are nothing but the baffle. Then the thermal well, if you want to measure the temperature of this liquid, then thermal well is provided, from which you can dip the thermometer and measure the temperature. Of course, inlet is provided at the top and discharge portion is provided at the bottom. So this is the agitated vessel. Let's talk about the dimension. Other things we have already discussed. This is the vertical tank. The height of the vessel ranges from 1.5 to 2 times of the diameter. See, if the height is, let's say, ranges, if its diameter is 1.5, then height going to be around 3 in terms of meter. If the diameter is 1.5 meter, then the height will be 2 times to 1.5 of the diameter, right? Then the impeller diameter is usually 1/3 of the tank diameter. So this impeller diameter is 1/3 of the tank diameter. In agitated vessel, impeller creates flow pattern, causing the liquid to circulate through the vessel and return eventually to impeller. So what happens, this impeller will provide the circulatory motion. I am going to show you those figures later on. And once this pattern is created, this liquid will flow through this vessel and again come back to the center. An agitator is a combination of impeller and shaft. That is, impeller is attached to the shaft. So this agitator is a combination of impeller and shaft. Now, as I already told, these are the vertical strips which are mounted to the wall of this agitated vessel. These are known as baffle. Use of baffle in vertical vessel is very mandatory, very essential for efficient mixing action. So to increase the performance of the mixing, you need to have the baffles in the tank. Otherwise, the vortex formation will created and then mixing performance drops. Baffle are the flat vertical strips which are mounted against the wall of the vessel, as you can see in this figure. So these are the baffles. It is common practice normally to use the 4 baffles in the tank so that you can avoid the vortex formation and you will have the proper mixing takes place. We are going to talk about the vortex formation in coming slides. Now the width of the baffle. So what should be the width of the baffle? The width of the baffle is 1/10 of the tank diameter. It can be 1/12 also. So 110 to 1/12 of the tank diameter. And the baffle height should be at least twice the diameter of the impeller. So if the impeller diameter is 2 meter, then the baffle height going to be around 4 meter, right? So these are the standards for this agitation vessel. There are various types of the impellers and so the agitators types. The term impeller and agitators are used interchangeably. When we say turbine impeller, it is also termed as turbine agitator, right? That we have to understand. Now, as we keep on talking about the baffle and use of baffle, let's say what the unbaffled tank will look like. Fine. This is the unbaffled tank. You cannot see the vertical strips which you were earlier saw in earlier slides. See, the vertical strips is not mounted against the wall. So this tank is basically the unbaffled tank, as you can see. And you can see the drop in the liquid level, right? Draw at the corners, right? So vertically vertex, we have given name the vertex. So vertex is what basically rising the liquid level at the wall and lowering the level at the shaft. So you can see the liquid level just rises at the wall and it has lowered at the center, right? At the shaft. So that is the nothing but the vortex formation. Also, when we not put the baffle, the swirling motion of the liquid takes place. So when this situation takes place, then the mixing performance decreases. So baffle normally used to improve the performance of the mixing operation and avoid the vortex formation. So as you can see, this vortex is formed, and because of that you can see the drop in the liquid level at the center observed, and the pattern of the flow is got disturbed, as you can see. So proper mixing has not been taken place, and that's why it is very important to use the baffle. Or there are also another ways to avoid the vortex formation or prevention of the swirling motion. Which are those ways? You can use baffle, as I already told you about this thing, or you can have the up center angular and side mounting of the impeller can be done. So if you just off center the impeller, still you can avoid the vortex formation. Side entering is also one of the good option to avoid the vortex formation, and baffling, use of baffle, as I already told, that is always the good option. Now see in this diagram, this propeller is just off center. See, it is not at the center. So this vortex formation is avoided. The liquid has not dropped its level at the center. So vortex formation has been avoided, and the proper circulation of the liquid inside the tank can be observed, isn't it? Again, in the second diagram, again the off centering of the impeller you can see. Again, the motion is, quite good, and again the vortex formation is avoided. So propeller for off center and angular unbaffled tank. The next important is side entering. When you provide the side entering for, the container or vessel, see, again the vortex formation has been avoided, and also the proper circulation has been observed for the liquid inside the tanks. So these are the different ways to avoid the vortex formation. You can put the baffle, or you can up center the impeller, and another way is what basically you can have the side entering for the container. So in this lecture basically we learn what is mixing and what is agitation. Mixing and agitation are not same. agitation is provided to improve the performance of the mixing operation. Then we came to know what are the dimension, standard dimension for agitated vessel, right? Then we came to know the importance of the baffles and how to avoid the vertex formation and what is vertex. So these things in this video we have learned. So thank you very much.